All right. Hello, everyone. Welcome to our stream today. We're going to be talking about evals on Llama 3.1 versus Llama 3 for RAG. And we're joined today by Nina Lopatina from Unstructured. For the first minute or so, I'm just going to let some of our intro slides play while people kind of like get into the room, and then we'll get started with this talk at about 9:02. If you're here, feel free to drop where you're coming from in the comments and what you do, anything like that. During the talk, if you have any questions, please feel free to add questions into the comments, and hopefully at the end of the talk we'll have time to address some of these. Yeah. Okay. Cool. So it's 9:02 a.m. and we're going to get started. So I'm going to take my slides off. I'm going to put these slides up, and I'm going to let Nina introduce herself.
Thanks, Eugen. So yeah, I'm Nina. I'm a staff developer relations engineer at Unstructured. And today I'm going to talk about how you could approach evaluating RAG performance on a system built on your unstructured data. So I'll start with a little bit of a background from about Unstructured. As a company, we are just about 2 years old, and you may already be familiar with our product. We have a lot of users. We have an open source repo and a serverless API and platform that we're launching soon. So we just do one thing, and that's make your human-generated data machine readable. So we support a wide range of formats. And we kind of fit in this ETL stage before you want your data in vector storage or a knowledge graph or a fine-tuning platform. And so for today's tech talk, the tech stack is going to be Unstructured, RAGAS, GPT-4.0, and we're going to be comparing Llama 3.1 and Llama 3 and using LangChain to stitch it all together, and it's going to be super easy. So where we fit in the stack is we do this kind of orchestration between whatever source your data might be living in. It might be in Google Drive or S3 or local on your computer, and whatever file format you have, we just take all of that and put it into JSON, and then we can chunk, summarize, embed it, and sync it to your vector database of choice or other cloud storage. And we process files with a few different sorts of methods. We do fast methods for files that contain text, and high res for image-based methods, and also third-party APIs for other features. And then we're going to be using RAGAS for metrics for evaluating our RAG system. So they have a number of scores in their open source repo that they've developed. So they have a faithfulness score of how accurate the answer is, answer relevancy, how relevant it is to the question, and there's also retrieval metrics like context precision and context recall. And I think they added a few more since they made their initial little chart of metrics, and they also have answer semantic similarity and answer correctness. So we're going to be calculating all of these using their tools to both create the question and answer data sets and calculate the metrics. So the faithfulness score is how many claims can be inferred from the context over the total number of claims. The answer relevancy is the mean cosine similarity of the question to a number of artificial questions. And answer correctness is semantic similarity between the generated answer and ground truth, and factual similarity. And then we're using GPT-4o as the generator for the ground truth, for the question generation, the ground truth generation, and then as the judge. And that is simply because in the chatbot arena leaderboard, it is, at least when I made these slides late last week, it is still the most performant model. And so the tasks that we're having it do, really, ideally, you would have a human do them, but humans don't scale well. So this is the next best option. And then we're evaluating Llama 3.1 because it was, I don't know, for me, it was very exciting when it came out last week. I am really excited about this open source development. And so they have made a model that really can compare with some of these top models that are proprietary in the open source. We're not going to be evaluating the 405 billion parameter version because we're doing everything in a free Colab notebook. We're looking at the 8 billion, but you could easily use the same approach for another model if you had some GPUs to run it on. And so these models have, over Llama 3, they have a longer context window, better tool use and reasoning capabilities, and they've also updated their license. And so from their own evaluations, the performance of the 3.1 series of models was intriguing. And so that's what we'll be evaluating. And I'll go over to share my notebook screen now. So I'm just going to unstructured.io to find the notebook, going to our documentation and example code. And here's our Llama 3.1 evaluation on unstructured text.
I don't think we can see this tab.
Oh, I guess I have to do, this, okay. Well, we missed a few of the steps, but it's just in our documentation. Thanks. So I'm just going to make a copy in Drive. So yeah, I'm going to start.
Can you zoom in a little bit so we can read the text? Thank you.
Is this better?
That's better for me. We'll see if the chat says anything.
Yeah. So I'm going to just start by just doing the pip installs while I go through some of what I've written up here, because those might take a little bit. And yeah, as a spoiler, I put the results up at the top, little TLDR. The performance for Llama 3.1 on a limited, I'll say it's just one PDF that we process here. And it's just an 82 question test set. But at least from this very small scale evaluation, the faithfulness has gone up dramatically. And the answer similarity and answer correctness have also made significant improvements. So I thought that was pretty exciting. If I was considering running, switching from Llama 3 to 3.1 in production, I would definitely do some more evaluations, and this kind of first one is very promising. So yeah, so first we'll be transforming the PDF, and then we'll be creating a synthetic data set, and then I just picked a recent paper on arXiv about how faithful RAG models are. But if you want to follow along, you can just swap out a different URL to where I've put this in. So yeah, and then I wanted to give a shout out to my colleague Maria, who had made a notebook about the RAG system setup, quantization and setup that we use here, that I borrowed some code from, as well as an earlier notebook I made on test set generation. So yeah, so getting started here, we have pip installs for the unstructured and LangChain and transformers libraries in RAGS. And then we're using the unstructured API in this example. So you could also equivalently or similarly, you could use our open source tool, but our API has a 2-week free trial for up to 1,000 pages per day, and it will have faster and more performant document extraction. So there's all the pip installs. I also have to do this pip install upgrade transformers because the exact framework I had for setting up the RAG system didn't want to work with Llama 3.1 if I didn't do this, even though I did a pip install just earlier. So then we are, I'm using Google Drive to like save files and stuff and have my .env file in there. I always like to note that like I gave this notebook permission to access my Google Drive, but it's the notebook that has the access, not any of the other providers linked in here. And you could very easily just download this notebook and run everything locally if you prefer to not give it access to Google Drive. I just do that because it's a little bit easier for me. So I loaded my .env file. I'm saving some of the paths. So this notebook takes like an hour to run. So we're not going to be running all of the sections live, especially getting 82 answers generated. And so there's a lot of sections where I'm saving the progress so far so that you can just pick it up later, because sometimes these notebooks time out. So here I'm starting the unstructured client. And then this is the path to the PDF that I wanted to process. So here we're downloading it. And then we're partitioning the file. We're chunking it by title. I chose 512 character chunks. I didn't really optimize this part of the process because I really wanted to try this out to see how the evaluation framework works and things like that. And then we're taking the text out. And so we're doing this just on a small scale, especially because we just want, we don't want to like take a whole set of documents and embed them. For this, we're just trying something small because this notebook takes about an hour to run through. So I ran it once to get the Llama 3 results, and then I had to run it again for another hour. But with Unstructured, you can swap out this processing for the ingestion setup in our documentation, and then you could just link it to a whole directory and then grab and also embed it and just grab that if you want to do this at scale. So here we're using LangChain to get the documents formatted in the way that Ragus wants to see them. And here we are setting up the test set generation. So I chose GPT 4.0 as the, actually I wouldn't recommend 3.5 anymore. We're using that as the generator LLM and also the critic LLM. And we're also generating the embeddings for this, for these questions and answers. And we are also setting the question type distribution. So I just picked an even split of simple, multi-context, and reasoning questions. And then this is where you would run the test set creation, but I have already run through it and saved it. So it's just loading that just to not have duplicate API calls. And then I had to do a little bit of cleanup of those because you would get like not a number or like the string version of it, or I didn't want to evaluate ground truth where the answer was the answer to a given question is not present in context. So I had generated 100 questions and ground truths, and then I ended up with 82. So that's why my test set was 82 and not 100. So I guess if you wanted a larger test set, I would aim for more because you'll end up filtering. This was just something I ran to just like take a look at a few of the questions. And I will say I first made this notebook when Llama 3 came out last May. And so I did look at one question. I kind of looked at some of the questions for a sanity check. And I think that the questions in ground truth have improved since then. I'll get to that toward the end of the notebook, possibly from an improvement in GPT 4.0 or from an improvement in the RAGAS framework. But synthetic test questions, you always kind of want to sanity check them. And when I looked at them, some of them were pretty good. And then, for example, there was a question on which model helped assess GPT-4's RAG, and it was not GPT 3.5. GPT-4 was actually the one assessing in this paper. So that being said, I would say it's helpful to actually look at the questions and answers to get a sense of how you want to interpret the results. And then, so here I have to use Llama 3 or 3.1, you have to go to the models page. So here, I'll just do the notebook login here. And before that, I had set up access to the weights of the model. So that is a little bit of a lead time item. If you want to do this, you want to go set that up. It usually takes about 10-15 minutes to get the approval. And so we then quantized the model. First we set up the retriever. And we're just doing a local, and I also don't know why. The recommended way to do the Hugging Face token in a notebook is the one I put here, but then it'll also ask for the one in my Google Drive secrets. So that's a little bit of a bug in the notebook, I guess. And so here I'm doing, setting up a local face, that's how you pronounce it, vector database. And then here is where we will be tokenizing the model so that we can run everything on this free Google Colab notebook. And then after these steps is where we would be setting up the the RAG chain. So this is the prompt format that my colleague Maria recommended for getting the best results. And so we're going to be doing all the imports and setting up the format docs function. And here we're setting up the RAG chain. And so, we defined the model, I think higher up somewhere. For the prompt, it's just a very simple prompt. I guess, if you were going to try this out on a different paper, you would want to tweak the question a little bit. Just a few things like saying, I don't know if you don't know the answer, and not making up to discourage hallucination. Yeah, and here the RAG chain is getting set up. So yeah, this is kind of a quick and simple example, but if you wanted to improve your model's performance, you could try this flow with the evaluation and try tweaking the prompt and seeing if like a more elaborate prompt might help you get better responses by comparing the results. And similarly, like the chunking strategy I used was not optimized. So this is a great setup to kind of start with and then tweak parameters to see if you can change your performance. So yeah, so this will take a little bit of time to run. I guess we can go back up to our sample question after that runs. Here, this code, yeah, here's where we're setting, where we're seeing which answer column to look for in the data frame based on the model version that we set earlier. And I'll note that this notebook right now is set up only for Hugging Face models. So if you wanted to try other models, you would need to make more tweaks to the RAG system setup plus the prompt. Yeah, so we would go through, if I didn't already have it saved, we would find that the answers would get generated, and this takes about half an hour to run to get each question from the locally running Llama 3. And I'm not going to save it now because we already are running the saved one. And yeah, I guess, okay, now it's going through the question here. So yeah, so this was just like a, this was a quick check of the RAG system. And we just wanted to see, like, did the answer seem reasonable? So yeah, we're not regenerating those answers, but here we are going to run our whole evaluation. So here we're kind of processing the data from the data frame where we were storing, or all of our evaluation data. So we just need the questions, ground truth, answer, and contexts. And we're also dropping null values because those will break the evaluation pipeline here. We're reformatting the data into a dictionary list. And then we're setting the specific metrics that we want for the evaluation. And then, yeah, so, yeah, and this is where we would run through this whole flow. So since I ran through this notebook a few times before, I already had the questions saved from Llama 3 and Llama 3.1. And this will save the, or I guess this will go over here. There's the null answers that are removed. So this is not actually factored into the metrics, but I'm just like printing it here for reference. Because if you put the null answers in, the pipeline won't work. So for Llama 3, there were 11 null responses removed. So actually the metrics should be even worse because of those, but they were not factored in. So I guess that's one drawback to the RAGS framework. But yeah, so we basically then run this data set transformation plus evaluation pipeline for each of the models. So it takes about a minute or two to run for each one. And Llama 3.1 had no null values, which is another plus to that model. And then I just print the results, and these are what I had calculated from an earlier run, using tabulate to make the table look a little nicer. And so the context precision and context recall, I'm not putting a ton of stock into those because I think those are based a lot on the context that GPT 4.0 was picking. And I think I had a short chunk size. So I think I haven't really put a lot of stock into those metrics in interpreting the evaluation. But yeah, as I had mentioned at the start, there are noticeable jumps in faithfulness, some improvement in answer relevancy, and then the answer similarity and correctness looked really improved. And then one other thing I wanted to note, that's just a fun aside about working with language models this day and age. So I created this notebook in May, and then I had rerun it with some minor changes earlier this month. And I had initial metrics for Llama 3 that were much better. And honestly, from my subjective evaluation, didn't really line up with what I was seeing. I thought the responses were not that great. And then when I reran it, there was a major drop in faithfulness, in answer relevancy. And this is just rerunning literally the same code with Llama 3 and just several months later, and not really changing much in the notebook. Nothing that would affect that evaluation. And so I'm going to guess that there was either better question answer generation by GPT 4.0 or better evaluation by it, since that was likely updated, or there was an update to the evaluation flow by RAGS. But actually, I find this notebook to be much more useful from the first time I ran it, because I think that these metrics now, they reflect my subjective evaluation much more closely. So yeah, not the first time I made a notebook and it worked better months later without my having done anything, but that's just a fun thing about developing with language models this day and age. So yeah, that's kind of the notebook flow. I guess if there are any questions, we can talk about those.
Have you tried this on other eval frameworks?
I have not. Have you?
I haven't either. But I haven't used RAGS to do any evals. I've mainly been working with Phoenix from Arise to do evals. So this is a look at a different framework.
Yeah. How does Phoenix work, or how does it compare?
I think they have you can kind of define your custom metrics as well, but it's a little bit different in terms of what's provided internally. So, or I guess natively, I don't know. They have hallucination and correctness and stuff like that. And then Truera, which I'm actually not sure what's going on with Truera since they got bought by Snowflake. But Truera had this groundedness, contextualness, and whatever kind of stuff to their framework as well. So it looks like there's a lot of very similar, let's say use cases or ways to evaluate these things.
Yeah.
But yeah, maybe I'll have to try out RAGS and give my opinion on how it is.
Yeah. Yeah, I just picked it because it was open source and it was pretty lightweight to implement. And I don't do much RAG evaluation in my work. Like we focus on pre-processing at Unstructured. So I just wanted to try it out to kind of see what the end of the pipeline looks like.
Cool. What's next for you in terms of these notebook or this notebook, I guess, or any of this kind of like type of work?
Yeah, so usually when I finish a notebook, it's kind of done and it's just like in our documentation. This one I ended up refreshing because I wanted to update it to Llama 3.1 since we were going over it in this webinar. I've got a couple of things that I'm working on right now. One is an update to the, I'm not sure if you pronounce it as Dancer or de-answer. It's like a chat with your office docs, like RAG in a box kind of repository. And so I'm making some tweaks to it to do the processing with Unstructured rather than some like default open source PDF processor that they have, to then kind of look at how that compares to the performance of the RAG tool. So I guess I will be doing more. I mean, if you're doing anything with RAG, you have to have evaluation as part of your workflow. So I guess I'll be doing, might be adapting some of this for that. And then I'm also working on a collaboration with Hex, which is like a data analytics and notebook tool. That's an alternative to Colab for some quantitative reasoning with tabular outputs. So kind of generate the tabular outputs, and then they have like code magic to write SQL queries or pandas queries that can let you ask questions about the table. So those are kind of a couple of near-term items.
Very cool. How do you feel about using Llama 3.1 for evals?
Like using it as the evaluation model?
Yeah, instead of GPT-4o.
Yeah, so I think if I could use the 405B model pretty easily, which I guess potentially you could access it via the Hugging Face API, I guess. I'm not sure if that's like an instantaneous thing once they release the weights. I think if there was like, either via an API or if I had just like a GPU machine to run it on locally, then I would swap it out.
You can use 405B on OctoAI right now. It's on experimental.
Oh, what does that mean?
You can use the Meta Llama 3.1 405B like via OctoAI's API right now.
Oh, cool.
Yeah.
Okay.
So if you want to try it out, check it out.
Yeah, I think I would definitely consider using it as an alternative because it does seem, at least from their own reports, that it would be comparable. Yeah. I wonder if the Ragus flow, like they have their own prompts like under the hood, which is kind of what I liked about using it. You just specify which metrics you want. I do wonder, I guess you set the model so they would know which model you're using. So presumably they may have different prompts per model. So I don't know if they would have them for Llama 3.1 yet because it just came out. But that would be like my only concern about how it would work. Like I have only tried 4.0 in this framework.
Cool. So we do have a question from the audience. Okay, there it is. How long does it take to process that one PDF? And how do you optimize for a real world use case with thousands of PDFs?
So I feel like, to scale this up to thousands of PDFs. So like one part that would scale pretty well would be the file extraction with Unstructured. So in our documentation, you could use one of our ingesters and our ingestion pipeline and then set some of those parameters for higher parallelization. That we actually have some updated documentation coming out on soon, because speed is important. And that would prepare a bunch of your documents rather quickly. And then for the test set generation, it doesn't take super long, but I guess maybe you could parallelize that as well by just like splitting your data outputs that you generated initially into buckets, and then running the test set generation in parallel. And because I'm kind of going through like any of the steps that take more than a few seconds. And then the very slowest part is generating the answers. So when I did run this, I did get a complaint from the model that I was putting it in each question one by one. So I guess you're supposed to pass a data frame. So this definitely could have been a little bit more optimized. But yeah, the main bottleneck is your own RAG system. So I guess whatever you could do to speed it up, like throw more compute at it, parallelize it more. Again, like these questions, you could break down into like 10 sets of questions and run those all in parallel. So I would say, yeah, that part you could split up. And then for the final evaluation, that took 2 minutes for 82 questions. And so I guess this would be harder to parallelize because you want the metrics output at the end. So maybe that part, I don't know. I guess maybe there could be other tools out there that do the evaluation faster. So yeah.
I think the question was about like the PDF ingestion. Can we parallelize like PDF ingestions?
Yeah. Oh, so the one PDF, I meant through the entire notebook. Like the processing of the one PDF in terms of ingestion, like we ran that here, that was 57 seconds.
Okay, there we go.
Yeah. And this did not have anything parallelized in the processing.
Okay, cool. Let's see. There doesn't seem to be any more questions for the moment. I think I've asked a couple of questions about what I would like to know. So someone says, thanks, Dan. And yeah, I think we can wrap it up here, unless you have anything else that you want to convey, Nina.
No. I guess if anyone wants to try out this notebook, feel free to ping me if you have any questions.
Send me the link and I'll put it into the chat, actually.
Yeah. Or I guess, where should I? Oh, okay.
Oh yeah, you can just put it into the private chat, and I'll just unless you can send it to the regular chat. Log into like StreamYard to do that. So
yeah,
for most presenters, I just like do it for them.
Yeah. But yeah, let me just share where I found the notebooks. So on our website, if you go to documentation and then example code at the top, then we have a lot of different notebooks about different tweaks on RAG or different quick starts for different vector databases, things like that. And we're continually building this out. So you can find that notebook or others there. So yeah, if you try it out with your own file or scale it up or anything, I'd be curious to hear the results.
Cool. All right. Thanks, Nina.
Thanks, Eugen.
For coming. And I'll see you guys in a couple weeks. Peace.
Bye.